All right. So we are working with theorem 6.5. Which is the side angle side inequality theorem. And it is a theorem that compares two triangles to each other. It says if two sides of one triangle are congruent to two sides of another triangle, but the included angle in the first triangle is greater than the included angle in the second triangle, then the third side of the first triangle will be longer than the third side of the second triangle. So, if two sides of one triangle are congruent to two sides of another triangle, but the included angle in the first triangle is greater than the included angle in the second triangle. Then the third side of the first triangle will be longer than the third side of the second triangle. So we start with two triangles where we have congruent sides. This side and this side are going to be congruent in both triangles. But we need to obviously be able to see that the included angle in the first triangle is in fact larger than the included angle in the second triangle. So when I finish out that third side of the first triangle and the third side of the second triangle, what we're going to be able to prove is that the third side in the triangle that has the larger angle will be the longer side. So I have triangle ABC and triangle DEF. My given information is that AB is congruent to DE, BC is congruent to EF, but measure of angle B, and I'll call it angle ABC. Because I'm going to draw another ray in the middle of that, is in fact greater than measure of angle E. What I want to prove is that segment AC must be longer than segment DF. Now, what I'm going to do to work with this is I'm going to draw a ray BZ that gives me an angle that's congruent to angle E. So we're going to draw a ray BZ that has an angle there, makes an angle with BC that's congruent to angle E. Now when we do that, we're going to mark off on this ray a point X so that BX is equal to ED. So we're going to put a point X on ray BZ so that BX is equal to ED and AB. The thing is X may be out here or maybe in here, okay? X will either be on AC or it will not be on AC. We're going to have to work with two cases because depending on where the opening of angle ABC is, that moves the point X around, okay? Which means we are going to have to work with if X is on AC, which is the easiest case, what happens, and if X is not on AC, what happens. Either way, we are going to be drawing the segment from X to C and looking at triangle BXC. So let me go ahead, give myself more room and start writing this proof because we need to start with describing what is BZ and why did we draw it there and then where is X. So we're going to draw ray BZ so that angle ZBC equals angle E. Put a point X on ray BZ so that BX is congruent to ED and AB. From looking at this picture, no matter where point X is and what that triangle looks like exactly, we still have triangle XBC will be congruent to triangle DEF by side angle side. Which means that segment XC will be congruent to segment DF. So in each case, those two segments will have the same length by corresponding parts congruent, triangles congruent. Now either X will lie on AC or X will not lie on AC. So we're going to have to prove both cases. X lies on AC, it's actually the easier case to prove because we see that AC is greater than XC. So by substitution, since XC and DF are equal, AC will be greater than DF. Because we know XC and DF are equal in value. If X does not lie on AC, then we have the harder proof, and that's where this proof gets difficult. So we'll have to draw another diagram that represents this other situation. So if X does not lie on segment AC, then the diagram looks like, and we'll go ahead and draw the diagram so that we see that case. I would like to, if possible, copy this diagram somehow. So I can move it down there and kind of do it the cheater's way of using that same diagram again. Okay. So I'm going to shrink this back down because we no longer need it so large. And we can move this stuff up. Let's make this diagram look like it's supposed to look. Let's move point X out. We're going to take that segment off because we have to draw it someplace else. Moving point X out. And it's moving slow. Okay, now I've moved too far. I'm going to exaggerate where X would be, just so we have a nicer picture. And it depends on where the diagram is. We could actually play with geometry sketchpad here. We went to geometry sketchpad, got a new diagram. Let's label it the same way. So we have DEF. We have X right here on ray BZ. We know that BX and BA and DE are all the same length. We know that BC and EF are the same length. We know that this angle is the same as that angle. Okay. We know that triangle XBC is congruent to triangle DEF, which means that XC is the same length as DF. Those are the things that we know about this diagram. It's just now X is not on AC. So what we are going to do is we're going to draw the angle bisector of angle ABX. And when we draw that angle bisector, I know that when I go from this point where that angle bisector crosses AC to point X, then we have triangle A, B, and we need to name that point something. So let's name it Y. Y is that point right there. So we have triangle ABY that's congruent to triangle XVY, which means that AY and XY are the same length. Okay, so continuing on, we'll write this part of the proof, I guess, in this empty spot here. When we draw angle bisector BX, BY is actually the angle bisector. Let me make that correction. Bisecting angle ABX. Then what we have is congruent triangles ABY and XBY. And that would be because they have a shared side BY, they have congruent angles, and BX and BA are congruent. So by side angle side. Which means AY and YX are congruent. Now, since YX plus YC, looking at triangle XYC, two of the sides added has to always be longer than the third side. So since YX plus YC has to be greater than XC, and that's by the triangle inequality theorem, then by substitution, because AY and YX are equal, AY plus YC has to be greater than XC. And AY plus YC is AC. So AC is greater than XC. But notice XC and DF are the same length. So by substitution, AC is greater than DF. That is what I want to prove there. Okay. Was I in the way all the time, Dustin? Sorry. Theorem 6.6 is the side-side-side inequality theorem. And because we have theorem 6.5 to lead to a contradiction, we're going to do a indirect proof for theorem 6.6, and it goes rather quickly. So, theorem 6.6 says, if two sides of one triangle are congruent to two sides of another triangle, but the third side in the first triangle is longer than the third side in the second triangle, then the angle opposite the longer side will be greater. Justin, are you taking notes there? Okay. All right. So we have two triangles then, and we're going to have congruent sides. So these two sides are going to be congruent in both triangles. But we have to make it so that the third side of one triangle is obviously shorter than the third side. So let's put these two sides closer together then. This third side will be longer than that third side. So we have triangle ABC and triangle DEF. What our given information is that you guys are having too fun with this. Okay? Is that AB is congruent to DE, BC is congruent to DF, and finally, AC is greater than EF. What we want to prove then is that, in fact, the angle opposite the longer side, which would be angle B in this case, is greater than the angle opposite the shorter side, which would be angle D. So we're going to prove that angle B is greater than angle D. So since we're doing an indirect proof, we're going to start by assuming the opposite of what we want to prove. What is the opposite of angle B is greater than angle D? Less than or equal to, yeah. So we're going to assume temporarily, we'll do this in red over here in this space, the opposite of what we want to prove, which is measure of angle B is less than or equal to measure of angle D. We have two cases here actually. The or equal to case would mean that these two triangles are congruent. By side angle side. which means AC is equal to DF. Equals EF, I mean. If measure of angle B is less than measure of angle D, then what we have actually is, by theorem 6.5, AC is less than EF. It is less. Both of these are contradiction to the given that AC is greater than EF.